All right, today I think it's going to be a long one, but it's going to be a cool one because we're going to get into the rules of implication and we're going to see how we can construct proofs using the rules of implication. Now, let's just get right into it. We're going to start off with 4 different rules of implication. So the first one is modus ponens. Modus ponens, which we will just denote MP. What we're going to do is we're going to use some statement variables here, right? And remember, our lowercase letter statement variables can represent larger, more complex statements using our logical operators. And so what modus ponens tells us, right, is that if we have something like here, let's switch up our color. Let's say we have P then Q, something of the form P then Q. And say we're also given P, right? So let's just imagine that these are premises we're given. P then Q and P. Then what we can do is we can derive Q from that, right? Say P was, what can I say? Say P is, if I go to the store, and Q is, I'll buy apples, right? So I have the statements, if I go to the store, then I'll buy apples, and I'm also given that I went to the store. So we should be able to reasonably conclude that I got apples, right? Hopefully, I just want to use like examples, so that way hopefully these can like make some sense. Now, after modus ponens is modus tollens. Modus tollens. We're going to denote these with MT, and it's important to know the names of all these rules of implication and their little shorthands. So what can we say with modus tollens? We could say that given the premises P then Q, and the premise not Q, what we can derive is not P. So let's use the same example. P is I go to the store, Q is I get apples. So I'm told if I go to the store, I will get apples. I'm also told that I didn't get apples. We can reasonably conclude that I didn't go to the store, right? Because I'm saying that if I go to the store, every time I go to the store, I'm getting apples, right? And today, I didn't get any apples. So that must mean that I did not go to the store. Because if I did, then I would be getting apples. But I didn't have apples, so I didn't go to the store. Okay, now the third rule of implication is a hypothetical syllogism. Look at these big words we're getting into. A hypothetical syllogism. And I'm really hoping that I'm spelling these right. HS. What is a hypothetical syllogism? Well, what hypothetical syllogism tells us, right? Let's get our yellow marker out now. Sorry, I paused the recording to sneeze, these allergies. Anyway, what hypothetical syllogism tells us is if we have P then Q and Q then R, what we can deduce is P then R. So let's say P is I go to the store, Q is I get apples, R is I make apple pie. And so I'm given that if I go to the store, I'll buy apples. And I'm also given that if I get apples, I'll make apple pie. So we can reasonably conclude that if I go to the store, I will be making apple pie. Because guess what? If I'm going to the store, I'm getting apples. And if I'm getting apples, I'm making apple pie. Thus, if I go to the store, I'm going to be making an apple pie. And now our fourth rule of implication is going to be a disjunctive syllogism. Disjunctive syllogism. You may be able to guess. We're dealing with our disjunction operator. Right, and this is DS. So what does a disjunctive syllogism tells us? It tells us that if we have P or Q, right? So if we have P or Q, and if we also have not P, we can deduce not Q. Oh, sorry. We can deduce Q. So let's say P is I buy apples, and Q is I buy oranges, right? Well, then from our premises, what I'm given is I buy apples or I buy oranges. Not P tells us I did not buy apples. So therefore we can conclude that I must have bought oranges, right? Because P or Q needs to be true. We know that P is false, therefore Q has to be true. Q must be the case. So now that we have these rules of implication, how can we apply them to proving arguments? Let's say I have an argument that looks like this. Let's say we have, Our premises are A, then not B. We have C, then B. We have A, and then our conclusion is not C. How do we do a proof? Well, the first thing we do with a proof is we list out our premises vertically, so like one on top of another, and we number them. So let's use different colors. We'll say number 1, right? We have A, then not B. So this is the beginning of a proof. We want to show that from our premises, we can derive the conclusion. So we have A, then not B. 2, we have C, then B. 3, we have A. And we don't have 4. We just have 3 premises. And then what we do is over here, we're just going to show the conclusion that we want to prove. We want to show that we can get to not C. And so now what we're going to do is use our 4 rules of implication, modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism, to somehow derive not C. How can we do that? Well, looking at 1 and 3, right? A, then not B, and A. Here, let's just go back up since we just learned these. From modus ponens, right? So we have something of the form P, then Q, and P. From modus ponens, what we can do is derive not B, right? So here's what we'll say. We'll say 4. We get not B. And we get that from lines 1, 3, and modus ponens, right? We have A, then not B. We have A, so we can get not B. Now, from 2 and 4, what we can do is get not C for modus tollens, right? We can say 5, we get not C from 2. What did I say it was from? It was from 2, 4, and modus tollens, right? We have C, then B, and not B, so we get not C. And if we look at our modus tollens up here, that's of that form, P, then Q, then not P. And there you go. We just derived the conclusion from our premises and using our rules of implication, so we have a valid argument here. That was pretty cool, right? So now what we're going to do is another example so we can really hammer this in, because these are difficult. There's no kind of intuition. There's no right way to do a proof, I guess, because there's a lot of different ways you can go about it. This one was pretty straightforward, but some of them, there's a lot of different roads that lead to the same conclusion. So let's look at this next example. Say I had the premises. What premises do I want? I want F then G, F or H, for H. I want not G. I want H, then G, then I. That's a G. G, then I. And my conclusion will be F, then I. So this is pretty complicated, but we're going to be able to do it from our rules of implication, just from the 4 we know right now. So let's start by writing out our proof. Let's number these premises. So we have for 1, F, then G. 2 is F or H. 3 is not G. 4 is H, then G, then I. And then our conclusion, which we're trying to show, is F, then I. Okay, now let's see how we can get here. Okay, so we want F, then I, right? And I'm going to try to explain my thinking for how I go through this. I is only found in the 4th step, right? H, then G, then I. So I probably want some way to get H by itself, so that way I can get G, then I. And then maybe if I could get G by itself, I can show G and G, then I from modus ponens will give me I, but then I need an F, then I. I don't know. Okay, so let's see where we can go with this. Okay, what is my first step? Okay, well, if you don't know where to start, the first thing you can do is just guess things by combining stuff that we already know, right? So I see in 1 and 3, I can use modus tollens to get not F, right? So let's try that out. Say 5, we can get not F from 1, 3, and modus tollens. Okay, so now that I have not F, I see from 2 and 5, I could get not H. I could get H from a disjunctive syllogism. So let's see, 6, we could get H from 2 and 5, disjunctive syllogism. Okay, I got H by myself. Well, now from 4 and 6, and modus ponens, I see that I could get G then I. So that comes from, where did it come from? It came from 4, 6 modus ponens. And now actually, I don't want to get I by itself. What I see is from 1 and 7, a hypothetical syllogism will give me F then I. So from 1 and 7, and hypothetical syllogism, I get F then I. I got my conclusion. And that's the end of the proof. We showed how we can get from the premises and our rules of implication to the conclusion. But we are not done for today. There are 4 more rules of implication. And if it hasn't been made obvious yet, you have to memorize these. It stinks because there's 8 rules of implication, and then we're going to go over 10 rules of replacement. But hopefully through these examples, they kind of make sense, and you won't really be memorizing them. They're just things that are like, oh yeah, obviously. Okay, so our next rule of implication is constructive dilemma. Constructive dilemma. Oh gosh, I actually have no idea if I spelled that right at all. It does not look right. Hold on, I think it's just 1 L and 2 M's. Constructive dilemma. Okay, and we'll denote this with CD. So what is a constructive dilemma? Well, constructive dilemma tells us if we have something like, what do we have? Let's say we have P then Q, right? P then Q and R then S. And then say we're also given P or R. What we can conclude is Q or S. So let's make sense of this. So let's say P, Q, R, and S. So we'd say P is I go to the store, Q is I buy apples. So if I go to the store, I'll buy apples. R is, I don't know, if it rains, R is rain, it's raining, and S is I'm sad. So we have, if I go to the store, then I'll buy apples, and if it's raining, then I'll be sad. That is what the first line tells us. The second line is telling us, I either went to the store or it's raining, right? I don't know which is the case. It could be that both are the case, but at least one of these is true. What I can logically conclude then is that I either got apples or I'm sad, right? Because it's either raining, which would make me sad, or I went to the store, which means I would buy apples, or both. I went to the store and it's raining, so I'm sad and I got apples. Hopefully that made some sense. The second one we're going to go over, the sixth one overall, is conjunction. Conjunction is actually super simple, a nice one to memorize. So we denote this with just conj, C-O-N-J. What does conjunction tell us? What conjunction tells us is that if we have, let's change up our color. If we have P and we have Q, we can just conjoin these and write P and Q, right? If you're given I bought apples and you're given I bought oranges, then you can just combine those and say I bought apples and oranges. That one's pretty straightforward. Actually, the next two are also pretty straightforward. We have simplification. Simplification is going to be denoted with the shorthand simp. And what does simplification tells us? Simplification tells us if we have something of the form P and Q, we could just simplify it to P, right? If I have the statement, I bought apples and oranges, both of those are true. So I can just simplify and just say, I bought apples, because that might be useful for something, for a proof. And then the last thing we're going to look at is addition. Addition, and this is denoted with just add. And what addition tells us is if we have any kind of statement, P, I can just add something onto it, P or Q, right? Because P or Q is true when one of those statements is true, and I'm given P, right? So if I said, let's say P is I went to the store, that's a true statement. Then what I could do is say I went to the store or I met the president. That's a true statement because we were given that I went to the store is true. I could say I went to the store and then say I went to the store or the earth is going to explode. That's a true statement because I went to the store. So now we have 8 rules of implication. So now we're getting into a little bit crazier territory. We can start doing some insane proofs. So let's look at 2 more examples using these new rules of implication. Let's say let's say I have these premises, and I'm just going to skip the part where I list them all out in the conclusion. I'm going to just start writing it in proof format to begin with. Can't write for some reason. Hold on a second. All right, that was weird. I don't know why I couldn't write, but let's get into it anyway. So I want to have, let's say, number 1 will be K then L. So remember, these are all just premises. 2 will be M then N and S. 3 will be N then T. 4 will be K or M. And the conclusion that I would like to reach is L or T. How am I going to do L or T? Okay. Let us think for a second. We have to really analyze what's going on here. Okay, I see a way out. So here's what we can do. On line 2, right? Let's just simplify that, right? Let's just get rid of our S and make this M then N. So M then N came from line 2 and simplification. Sim. All right. The next thing I see is that from lines 3 and 5, we can get M then T. So M then T comes from, let's say, M then T. That comes from lines 3 and 5 and hypothetical syllogism. So now we have M then T. We also have K then L. We have K or M. Okay, so now what I'm thinking, right, is we do conjunction, right? So we have M then T and K then L. K then L. So this is going to come from which lines? This is going to come from line 6 and line 1. And this is conjunction, so conj. Now, I see where we can do a constructive dilemma, right? Using line 7 and 4. So we have K or M, right? And what we can get from that is T or L. T or here, you know what? Just to be technical, because we're going to learn some rules of replacement, here's what I have to do. I'm going to rewrite this as K then L. We have to be real specific with our ordering. K then L and M then T. That came from lines 1 and 6 and conjoining them. And now what we can do is get L or T from line 4 and line 7. 4 and 7 constructive dilemma. I had to be particular with that ordering. You can't just go the opposite way. Technically, you can using a rule of replacement and a rule of implication, but we haven't learned rules of replacement yet, so we're just going to strictly follow the orders that we've learned, follow the form that we've learned. But anyway, that aside out of the way, we got L or T, we reached our conclusion, and there we go. And so we use, what did we use? We use simplification, conjunctive, and constructive dilemma so far. I think the only new one we haven't used is addition, but that's going to come up in this next example. We're going to have, let's say, number 1 will be not M and N. 2 will be, what do we have for 2? We have P then M. 3 is, I don't know what we have for 3. We have Q and R. And then for 4, we have if not P and Q, then S. And the conclusion I want to draw is S or T. As you can see, T is nowhere in any of the premises. So what I'm thinking right now is that's going to come from addition. So we get S or T by just getting S by itself and then adding T onto it. So how can we get S by itself? Well, line 4 is the only premise with an S in it. So I need not P and Q. How can I get that? How can I get not P and Q? Well, we could simplify line 3 for Q. And then if we simplify line 1 and use modus tollens, we could get not P. So that's what we're going to do. So what did I say we want? So let's simplify line 3, right? Let's say 5. We just get Q from line 3 and simplification. All right, now what I want to do is on line 1, I want to simplify that and get not M. So this came from 1 and simplification. Now from line 2 and line 6, we could get not P. So this is from 2 and 6 using modus tollens. So now we have not P, we have Q. I want to conjoin those, and I want to get not P and Q from line 5, 7, and conjunction. Now from lines 4 and 8, we can have, using modus ponens, we have S. So that came from, lines that I say came from 4 and 8, and modus ponens, yeah. And then finally from line 10, we have S by itself. We could just add T onto that and say this came from 9 and addition. And there we go. We got the conclusion we wanted to reach. So this is some pretty cool stuff. It's difficult, but it's pretty cool, and you're going to need to know how to do this for the entirety, for the rest of your class, for the rest of your logic class. It's never going to go away. In the next video, we're going to go over the 10 rules of replacement. If you made it to the end of this video, thank you for sticking that out. I know it's a long one. I really appreciate it, and I hope you learned something.